So in this class we are going to discuss about the particle nature of electromagnetic radiation. In previous video we have discussed about the wave nature of electromagnetic radiation. So electromagnetic radiations have dual character, wave as well as particle character. Regarding wave character of electromagnetic radiation we have discussed in our previous video. So wave nature of electromagnetic radiation supported by the phenomena of diffraction, interference, like that. So regarding diffraction, regarding interference, you have to study in physics. So wave nature of electromagnetic radiation supported by the phenomena of diffraction, interference, deflection, like that. So then today we are going to discuss about the particle nature of electromagnetic radiation. So related theory to this topic is Planck's quantum theory. That means we are going to discuss about the Planck's quantum theory. So before starting this topic, let us discuss about the black body and black body radiation. Black body and black body radiation. So before discussing about the Planck's quantum theory, then we have to discuss first black body and black body radiation. So black body is an ideal body. Black body is an ideal body which can emit and observe all the frequencies of radiation. So black body, it is an ideal body. मतलब black body is a substance. ये काला वाला बॉडी नहीं है, नाम दिया गया ब्लैक बॉडी. So black body is an ideal body. Black body is an ideal substance which can emit and observe all the frequencies of radiation. So black body ऐसा एक substance है which can emit and observe all the frequencies of radiation. So black body ऐसा एक substance है जो किसी भी frequencies of radiation को, electromagnetic radiation को absorb कर सकता है and किसी भी frequency of electromagnetic radiation को emit कर सकता है. So the radiation emitted by a black body is known as black body radiation. So radiation emitted by a black body, frequencies emitted by a body in the form of radiation is known as what? Black body radiation. So black body, it is an ideal body which can emit and observe all the frequencies of radiation. So black body radiation is the radiation which is emitted by a body is known as black body radiation. So black body, according to the, now we are going to discuss about the Planck's quantum theory. According to the Planck's quantum theory, black body emits or absorbs radiation discontinuously. किसी भी black body radiation emit और absorb continuously नहीं करता है, discontinuously करता है. That means black body radiation emit और absorb करता है just like a small packets of energy. So black body emits or absorb radiation just like a small packets of energy. Any black body emits radiation or absorbs radiation just like a small packets of energy. That means radiation consists of small packets of energy. That means radiation consists of the particles. Radiation consists of small packets of energy. That particles, that small packets of energy, that particles present in the radiation are known as क्वांटा. क्या बोला जाता है? क्वांटा बोला जाता है. प्लूरल में क्वांटा, सिंगुलर में क्वांटम बोला जाता है. So black body emit or absorb radiation discontinuously, just like a small packets of energy. So radiation consists of small packets of energy. That means radiation consists of particles. That particles present in radiation are known as what? Quanta. Plural में quanta बोला जाता है, singular form में क्या बोला जाता है? Quantum. So radiation consists of particle. That particles are known as what? Quanta. Plural में quanta, singular में quantum. So according to Planck's quantum theory, energy E associated with a energy E associated with a quantum of radiation is directly proportional to the frequency of the radiation. E is the energy of a quantum of radiation. E is the energy of a quantum of radiation. So energy of a quantum of radiation E is directly proportional to the frequency of the radiation. Suppose हम लोग proportionality sign remove कर दिया by putting a proportionality constant h. Now this equation is known as what? This equation is known as Planck's quantum equation. This equation is known as what? Planck's quantum equation. Or in this equation, what is capital E? E is the energy associated with a quantum of radiation, and nu is the frequency of the radiation, and h, it is known as Planck's constant. Planck's constant. What is h? H, it is known as Planck's constant. H is the Planck's constant, and value of Planck's constant is 6.626 into 10 to the power minus 34 joule into second. This is the value of Planck's constant h. You have to remember the value of Planck's constant h. So what is the name of this equation? This equation is known as what? Planck's quantum equation. So according to the Planck's quantum theory, energy E associated with a quantum of radiation is directly proportional to the frequency of the radiation. In case of light, that quantum are known as photon. In case of light, that quantum of radiation known as what? Photon. तो लाइट के लिए क्वांटम ऑफ रेडिएशन को क्या बोला जाता है? फोटॉन. सो एनर्जी E एसोसिएटेड विद अ फोटॉन. एक फोटॉन का एनर्जी फाइंड आउट करने से ये रिलेशन अप्लाई करना है. तो एनर्जी E एसोसिएटेड विद अ फोटॉन इज इक्वल टू हाउ मेनी? h nu. And we know that nu equal to c by lambda. We know that nu equal to c by lambda. C is the speed of light or velocity of light. Lambda is the wavelength of the light or wavelength of the radiation. So this is the mathematical form of the Planck's quantum equation. E equal to h nu. So this is the mathematical form of the Planck's quantum equation. So according to Planck's quantum theory, radiation consists of small packets of energy. That small packets of energy present in a radiation are known as quanta. So according to Planck's, according to the Planck's quantum theory, radiation consists of small packets of energy, comma, known as quanta, The energy E associated with a quantum of radiation is directly proportional to the frequency of radiation. So according to the Planck's quantum theory, radiation consists of small packets of energy known as quanta, quanta. The energy E associated with a quantum of radiation, सिंगुलर में क्वांटम बोला जाता है. The energy E associated with a quantum of radiation is directly proportional to the frequency of the radiation. So this is the E equal to h nu. This is the mathematical form of the Planck's quantum theory. E is the energy associated with a quantum of radiation, h Planck's constant, nu is the frequency of radiation. So in case of light, these quanta or quantum are known as photon. So calculate the energy of a photon. बोलने से you have to use this relation, E equal to h nu. So next we are going to discuss about the photoelectric effect. Photoelectric effect, it is a phenomenon. It supports the particle nature of electromagnetic radiation. So according to Planck's quantum theory, radiation consists of particles. Regarding the particle nature of electromagnetic radiation, supported by which phenomena? Photoelectric effect. This phenomena supported that radiation consists of particles. To explain this phenomena, H. Hertz in the year of 1887 carried an experiment. This is the experiment. He was carried in the year of 1887 to explain the phenomena of photoelectric effect. So in this experiment, it is a metal plate. This is a alkali metal surface. मतलब this is a metal plate. कौन से metal का plate है? Alkali metal. Alkali metals are element of group 1 in the periodic table. Group 1 elements in the periodic table are known as alkali metal. What are the alkali metal? Lithium, sodium, potassium, rubidium, cesium and francium. Fr. These are the alkali metals. These are the elements of group 1 in the periodic table. Everybody know it. There are 18 groups in the modern periodic table. Group 1 elements are called alkali metal and group 2 elements are known as alkaline earth metal. So this metal plate, it is an alkali metal plate. मतलब this plate may be lithium, sodium, potassium, rubidium, cesium. So why alkali metal is metal plate he has been taking? Because alkali metal easily eject electron. Alkali metal easily loses electron. Alkali metal easily loses an electron to attain the stable electronic configuration of group 18. Why elements, atoms of different element loss or gain or sharing of electron? To attain the 8 electrons in their valence shell. That rule is called octet rule. So alkali metals have greater tendency to lose how many electrons? 1 electron. क्योंकि उन लोग 1 इलेक्ट्रॉन लॉस कर देने से इजीली ग्रुप 18 एलिमेंट्स का स्टेबल कॉन्फ़िगरेशन अटेन कर लेता है. So this is the alkali metal surface. This is the alkali metal surface. This is a detector. So this is an electronic circuit. यहाँ एक electronic circuit बनाया गया. This is emitter. This is battery. Battery का लंबा. This indicate positive electron. छोटा वाला negative indicate करता है. So this is battery. This is emitter. Emitter क्या indicate करता है? Flow of current. Emitter measures the current flow through a circuit. And galvanometer indicates the direction of current flow. And emitter measures the quantity of current flows through an electronic circuit. So क्या जब ये metal plate alkali metal plate is striking by a radiation of definite frequency. This is the incident radiation जिसका frequency हम लोग कितना consider कर रहे हैं mu. This is the incident radiation. This is the radiation strikes the metal surface. H. Hertz observed that when a radiation of definite frequency strikes the metal surface, then current is flowing through this circuit. When a radiation of definite frequency strikes the metal surface, he observed that current is flowing through this circuit. करंट फ्लो क्या है बोलकर कहां से मालूम चलेगा? फ्रॉम द एमीटर. क्योंकि एमीटर का जो एंटीना हिलेगा करंट फ्लो होने से थ्रू द इलेक्ट्रॉनिक सर्किट. सो व्हेन अ रेडिएशन ऑफ डेफिनिट फ्रीक्वेंसी स्ट्राइक्स द मेटल सरफेस, देन व्हाई करंट इज फ्लोइंग थ्रू दिस सर्किट? करंट फ्लो मींस फ्लो ऑफ इलेक्ट्रॉन. करंट फ्लो मींस फ्लो ऑफ इलेक्ट्रॉन थ्रू एन इलेक्ट्रिकल वायर. Electricity is conducted by the electrons. क्योंकि इलेक्ट्रॉन इज चार्जेस कैरी करता है. 1 इलेक्ट्रॉन कितना चार्जेस कैरी करता है? 1.6 into 10 to the power minus 19 coulomb. So through this electronic circuit current flow हो रहा है. Current flow that indicates that electron is flowing through this circuit. तो इलेक्ट्रॉन कहां से फ्लो हो रहा है? क्योंकि जब ये रेडिएशन से डेफिनिट फ्रीक्वेंसीज ऑफ रेडिएशन से मेटल सरफेस को स्ट्राइक किया, देन व्हाट हैपेंड? फ्रॉम द मेटल सरफेस इलेक्ट्रॉन्स आर इजेक्टेड. इलेक्ट्रॉन इजेक्ट हुआ. दैट इजेक्टेड इलेक्ट्रॉन्स डिटेक्टेड बाय द डिटेक्टर. क्या क्या ये इजेक्टेड इलेक्ट्रॉन को ये डिटेक्टर ले लिया. देन इलेक्ट्रॉन क्या हुआ? फ्लो हुआ थ्रू द सर्किट. इलेक्ट्रॉन फ्लो हुआ मींस current flow through the circuit. That means when a radiation of definite frequency strikes the metal surface, then electrons are ejected from the metal surface, and that phenomena is called what? Photoelectric effect. So what is the photoelectric effect? When a radiation of definite frequency strikes the metal surface, then electrons are ejected from the metal surface having a definite velocity or definite kinetic energy. And that phenomena is known as what? That phenomena is known as what? Photoelectric effect. So why photoelectric effect supports that radiation consists of particle? So radiation consists of particle. In case of radiation, particles are known as quantum. In case of light, that quantum are known as photon. So photons are the particle, quantums are the particle. So radiation of consists of particle. जब रेडिएशन में जो पार्टिकल है मेटल सरफेस पे जो पार्टिकल्स है, मेटल सरफेस में क्या है? इलेक्ट्रॉन्स है. इलेक्ट्रॉन भी पार्टिकल, फोटोन भी पार्टिकल, क्वांटम भी पार्टिकल. जो फोटोन पार्टिकल आके क्वांटम आके क्या किया? इलेक्ट्रॉन का साथ स्ट्राइकिंग हुआ. ड्यू टू दैट स्ट्राइकिंग इलेक्ट्रॉन्स आर इजेक्टेड फ्रॉम द मेटल सरफेस. दोनों पार्टिकल का बीच में स्ट्राइकिंग हुआ, टक्कर लगा. रेडिएशन का पार्टिकल और मेटल सरफेस में जो इलेक्ट्रॉन है दोनों का बीच में टक्कर हुआ, स्ट्राइकिंग हुआ. Due to that striking, electrons are ejected from the metal surface having a definite velocity, having a definite kinetic energy. ये इलेक्ट्रॉन ejected इलेक्ट्रॉन का definite क्या होगा? Kinetic energy होगा. What is the relation to find out kinetic energy? Kinetic energy equal to half mv squared. So this is the relation to find out kinetic energy. So kinetic energy of a particle depends on velocity. When velocity of the particle increases, then kinetic energy of the particle also increases. So according to H. Hertz, what is the photoelectric effect? When a radiation of definite frequency strikes the metal surface, then electrons are ejected from the metal surface having a definite velocity or definite kinetic energy, and that phenomena is known as what? Photoelectric effect. So this is the definition of photoelectric effect. So according to the photoelectric effect, so when a radiation of a definite frequency or wavelength strikes the metal surface like potassium, rubidium, cesium metal surface, electrons are ejected from the surface, from the metal surface having a definite velocity or kinetic energy, and this phenomena is known as photoelectric effect. So this is the definition of photoelectric effect. So H. Hertz from this experiment, H. Hertz from his experiment, it was observed that the number of electrons, how many number of electrons are ejected from the metal surface, it depends on the intensity or frequency of the incident radiation. So from his experiment, H. Hertz observed that the number of electrons, how many number of electrons are ejected from the metal surface, depends on the intensity or frequency of the incident radiation. It is one of the observation from this experiment. Second observation, he observed that जब मेटल सरफेस में रेडिएशन स्ट्राइक करता है, as soon as electrons are ejected from the metal surface, there is no time gap between the fall of electron on the metal surface and ejection of electron from the metal surface. जब रेडिएशन स्ट्राइक कर देता है मेटल सरफेस से, as soon as electrons are ejected from the metal surface. So this is one of the observation. So these are two observation. Number of electrons ejected from the metal surface depends on intensity or frequency of the incident radiation. Second one, the electrons, there is no time gap between the ejection of electron and striking of रेडिएशन ऑन द मेटल सरफेस। जब रेडिएशन स्ट्राइक कर देता है, as soon as immediately electrons are ejected from the metal surface. Third observation, he observed that for the ejection of electron from the metal surface, definite frequencies of radiation, definite frequencies or wavelength of radiation must be strike the metal surface. मतलब मेटल सरफेस से इलेक्ट्रॉन रेडिएशन होने के लिए इंसिडेंट रेडिएशन का फ्रीक्वेंसी क्या होना पड़ेगा? डेफिनिट होना पड़ेगा। So the minimum frequencies of radiation that is required to eject the electron from the metal surface is known as threshold frequency. Threshold frequency. So what is threshold frequency? Threshold frequency is very important for you. So what is threshold frequency? The minimum frequencies of radiation is required to eject electron from a metal surface is known as threshold frequency. Threshold frequency denoted by nu naught. So इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी से कम होने से देयर इज नो फोटोइलेक्ट्रिक इफेक्ट। सो मेटल सरफेस से इलेक्ट्रॉन इजेक्ट होने के लिए इंसिडेंट रेडिएशन का फ्रीक्वेंसी, सपोज न्यू इज द फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन, इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा होना पड़ेगा, नहीं तो इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी का क्या होना पड़ेगा? इक्वल होना पड़ेगा। सो दिस इज द कंडीशन फॉर फोटो इलेक्ट्रिक इफेक्ट। सो इंसिडेंट रेडिएशन का फ्रीक्वेंसी जब थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा होगा और इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी का इक्वल होगा, then in that case electrons are ejected from the metal surface. And threshold frequency is different for different metal. Threshold frequency depends on the nature of the metal. Different metals का surface से electron eject होने के लिए different frequencies of radiation is required to strike the metal surface. So threshold frequency is different for different metal. जिस metal का threshold frequency ज़्यादा होगा, from that metal electron eject होने के लिए incident radiation का frequency ज़्यादा होना पड़ेगा। So कौन सा metal से हम लोग सबसे easily electron eject कर पाएगा? जिस metal का threshold frequency कमती होगा। So मोस्ट एप्रोप्रिएट कंडीशन फॉर द फोटोइलेक्ट्रिक इफेक्ट क्या होना पड़ेगा? इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा होना पड़ेगा। दिस इज द मोस्ट एप्रोप्रिएट कंडीशन फॉर द फोटोइलेक्ट्रिक इफेक्ट। इन दिस केस आल्सो फोटोइलेक्ट्रिक इफेक्ट इज हैपनिंग, बट इन दिस केस व्हाट हैपेंड? इजेक्टेड इलेक्ट्रॉन का वेलोसिटी क्या होगा? जीरो होगा। जब इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी इक्वल होगा, देन क्या होगा? इजेक्टेड इलेक्ट्रॉन का वेलोसिटी और इजेक्टेड इलेक्ट्रॉन का काइनेटिक एनर्जी कितना होगा? जीरो होगा। रिमेंबर इट। देन इफ इंसिडेंट रेडिएशन का फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन इज लेस देन द थ्रेशोल्ड फ्रीक्वेंसी, देयर इज नो photoelectric effect. In this case no photoelectric effect. In this case photoelectric effect नहीं होगा। फोटोइलेक्ट्रिक इफेक्ट होने के लिए आइदर इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा होना पड़ेगा और इंसिडेंट रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी क्या होना पड़ेगा, इक्वल होना पड़ेगा. सो नाउ suppose nu is the frequency of incident radiation. nu को हम लोग h से मल्टीप्लाई कर देंगे से ये क्या हो गया h nu means energy of a quantum of radiation according to Planck's quantum theory. So h nu represents the energy of incident radiation. Nu frequency of incident radiation, then h nu energy of the incident radiation. So h nu, this is energy of incident radiation. Incident radiation means radiation strikes the metal surface. Nu naught threshold frequency. When threshold frequency is multiplied by Planck's constant h, then this is known as threshold energy. Threshold energy also known as work function, and it is denoted by the symbol of work function, denoted by the symbol of W naught. So what is h nu? It is known as energy of the incident radiation, and h nu naught, it is known as threshold energy, also known as work function, denoted by the symbol of W naught. So different metals have different work function or threshold energy. One of the table given in your textbook, in the table for the different metals work function is given. टेबल को देखना है. In the table different metal के लिए क्या दिया हुआ है, work function दिया हुआ है. जिस metal का work function सबसे ज्यादा होगा, from that metal इलेक्ट्रॉन eject करने के लिए सबसे difficult होगा, और जिस metal के लिए work function सबसे कम होगा, from that metal electrons can be easily ejected. So देखो, this is the energy of incident radiation, this is threshold energy. Threshold energy depends on the nature of the matter, remember it. So what is the most appropriate condition for the photoelectric effect? Incident radiation का energy must be greater than what? Threshold energy. This is the most appropriate condition for the photoelectric effect. So incident radiation का energy threshold energy से ज़्यादा होना पड़ेगा. Then electrons are ejected from the metal surface. दोनों इक्वल होने से भी इलेक्ट्रॉन इजेक्ट होगा, लेकिन इजेक्टेड इलेक्ट्रॉन का वेलोसिटी कितना होगा? 0 होगा. सो h nu जब h nu से ज्यादा है, देन दोनों का बीच में क्या होगा? एनर्जी डिफरेंस होगा. h nu एंड h nu naught, दोनों का बीच में जितना एनर्जी डिफरेंस होगा, that amount of energy gained by the ejected electron is a kinetic energy. Kinetic energy. h nu and h nu naught, h nu greater than h nu naught. So दोनों का बीच में definite amount of energy difference है. So दोनों का बीच में जितना energy difference है, that amount of energy gained by the ejected electron as a kinetic energy. दोनों का बीच में जो energy difference है, that amount of energy is transferred to electron as a kinetic energy. So h nu naught, this is known as work function or threshold energy. So h nu naught का जगह हम लोग क्या लिख सकते हैं? W naught equal to kinetic energy का रिलेशन है half mv square. Then रिलेशन को अरेंज करने से h nu equal to हम लोग क्या लिख सकते हैं? half mv square plus W naught. And this equation is known as what? Einstein photoelectric equation. What is the name of this equation? This equation is known as Einstein photoelectric equation. So this equation is important for you. So this equation is known as what? Einstein photoelectric equation. देखो, जब h न्यू इक्वल टू, जब इजेक्टेड इलेक्ट्रॉन का वेलोसिटी 0 हो जाएगा, इजेक्टेड इलेक्ट्रॉन का वेलोसिटी 0 होना से दिस टर्म इक्वल टू 0, देन व्हाट हैपन, h न्यू इक्वल टू h न्यू नॉट. सो h न्यू इक्वल टू h न्यू नॉट कब होता है, जब इजेक्टेड इलेक्ट्रॉन का वेलोसिटी और काइनेटिक एनर्जी कितना होता है, 0 होता है. So some of the numericals related to the photoelectric effect, some of the problems are solved in your textbook. जैसे कि problem number 2.6, 2.8, problem number 2.6, 2.8, 2.9, problem 2.6, 2.6, 2.7, 2.7, 2.8, 2.9. These problems are solved in your textbook. Then you have to practice this problem from your textbook. These are solved in your textbook. Textbook में solve किया हुआ है. So photoelectric effect then supported the particle nature of electromagnetic radiation. So next day we will start another topic. So thank you.